All right, let's jump right into it. So looking at shading 5/6 of this rectangle, I think the biggest thing is making sure that your student understands that the 6 means there's 6 parts. And 5 means we're talking about 5 of them. When we're looking at what fraction is marked on this number line, again, we're seeing this time is kind of the opposite, like how many parts are there? There's 1, 2, 3, 4, 5, 6 parts. And this is the first one, so this is the first one out of 6 parts. So just to double check this one, I would have a student say, oh, well, that's 0, that's the first one, second one, third one, fourth, fifth, and sixth would get me to the whole. And so this is the first one, 1 out of 6. Where does the 1 go on this number line? This one is, I think, kind of fun and interesting, but we're trying to say, are they gonna put the 1 an appropriate distance away from 1/4? Right, so if it's 1/4, that means the whole must have been broken up into 4 parts. So we want to make sure they catch that. And if this is the first one, that means there should be 4 of these. So you can almost just like space it out. 1, 2, 3, 4, right? So it should be somewhere, I think, right around here. Are they getting pretty close to that? 1/4, 2/4, 3/4, 4/4. Looks like I made it a little bit too small, but that's okay. Does this rectangle show 1/3, 2/6, or both? It shows both for sure. And that's what we want them to see. We want them to see that this is a whole and it does have 1, 2, 3, 4, 5, 6 parts. And so it has 2 of them shaded, so it definitely is 2/6. But we also want them to see that it can also show 1/3, right? So this is one piece that is shaded, one piece that is not shaded, and one piece that is not shaded. So this could also be 1/3, 1/3, 1/3. How much is it shaded? 1/3, also 2/6. Looking down here, 4 halves. 4 halves. What is it equivalent to? We're going to jump to the next page really quick. It's important to understand that 4 halves means that I have 4 halves, like 1/2, 2 halves, 3 halves, 4 halves. And so I find that making sure students understand that that means that there is like a candy bar. If I'm thinking of a candy bar, I have 1/2, 2 halves means I have 1 whole candy bar, but I had 4 halves, so that means I need more than that. Another half and another half. Now I have 1, 2, 3, 4 of them, so that shows me 2 whole candy bars. If I think about candy bars again, but this time I'm comparing it to one of these other ones, like 2/4. Okay, again, the denominator tells me how many to break it up into, so I'm gonna break it up into 4 pieces. So going back here, here's my other candy bar. I broke it up into 1, 2, 3, 4 pieces. This is a 1/4, this is another 1/4, so this shows 2/4. We can see that that is way smaller than 4 halves, so not equivalent. Down here, this would be 1 whole candy bar, 2 whole candy bars, but I broke each candy bar up into thirds. So this is a 1/3. All of those are thirds, and so I'm saying with 6/3, is it equivalent to 4 halves? And we can see that 1, 2, 3 of those thirds means a whole candy bar. Another 1, 2, 3 of those thirds means another whole candy bar. So we can see, even though my drawing isn't perfect, that 4 halves is the same as 6/3 because they both are 2 whole candy bars. And then this last one, 1/2 is not. You can see it quite plainly here, 1/2, too small, not the same as 4 halves. So over here, which ones are equivalent? Well, 4 halves is equivalent to 6/3. Coming down here for which fraction is larger, 5/8 or 7/8, we want them to understand that 5/8 means there's 5 of them and there's 7 of them, but both pieces are the same size. So which one has more? Well, 7 is more than 8. We can show that, like on this number line right here. We can say, well, this means I have 5/8. So here's 1/8, 2/8, 3/8, 4/8, 5/8. Well, 5/8 is right here. 6/8, 7/8, 7/8 is right here. On this number line, we can see that 7/8 is larger than 5/8. Going down to which fraction is larger, 1/5 or 1/2, A lot of times kids will say that 1/5 is larger because they're used to seeing that the 5 means that it's bigger and the 2 means that it's smaller. But we have to remember that the denominator, this is way new to them. 5 means it's broken up into 5 parts. It's almost like you're taking a candy bar, you're sharing it with 5 people. Or same candy bar, but you're only sharing it with 2 people. Right, so we can show that here. Here's my candy bar, sharing it with 5 people means I'm gonna have a tiny piece. Sharing it with 2 people means that my piece will be a whole lot bigger. So we can see that 1/2 is larger than 1/5, or we could say 1/5 is less than 1/2. Last thing, which fraction is larger, 3/5 or 3/2? Now we can see in 3rd grade, we're talking about how the numerator is the same. So they're both 3 of something, 3 of something. Well, again, 5ths are tinier, halves are bigger. And so we might be able to see, oh, well, 3/2 is gonna be more than 3/5. But again, we want them to really show it. So looking down here, right? So 3 of something, there's 1, 2, 3 of something, and 1, 2, 3 of something. There's 3 of something on both. But this one again, the 3/5, broke this whole up into 5 parts, so the 3/5 is pretty small. 3/2 means I had 1/2, 2/2, 3/2 means I have more than one whole. I have one whole and another half, so 3/2 is actually pretty big. So 3/5 is less than 3/2. The biggest thing we want them to notice with these ones down here again is like this denominator tells me I'm breaking it up into smaller pieces. This denominator tells me I'm breaking it up into pieces, but not as small. Those are some big concepts for students in 3rd grade.